Hi, I'm Naz. I'm the CEO and founder of Rebel and the author of Developer Life and maintainer of the Rebel 2e crates. I believe that open source comes from an open heart and the joy of coding. In today's video, I'm going to do a deep dive of the, I guess I should say another deep dive of, or yet another deep dive of the nom parser. Typically, nom is used to take a bunch of bytes, specifically a slice of bytes, and then match certain patterns that show up, consume or take whatever's been matched, and then turn that into either throw it away, drop it, or turn it into some other type and then return that. So that's essentially it's a declarative parser, it's a functional parser, it's a combinatorial parser. So the kind of underlying assumption there is that what's being parsed is a slice of something, of a slice of some type, typically a bytes or strings. So for my Rebel 2e code base, I have a Markdown editing component, and one of the things that the Markdown editor does is it can take an array of bytes or a string, essentially either a string, caps S string, or a string slice, and basically a vec of U8, and then it can then there's essentially it uses a vec of string internally to represent a buffer. A buffer is like something that an editor can edit. So each line is a string, and if you have more than one line, or the first line is the first item in the vec, the second line is the second string in the vec, and so on. So I had some problems when I was actually, I mean still do, in the Rebel 2e code base. When a change is made to the editor, like to a buffer in the editor by a person typing something, that can then trigger, let's say, the underlying vec of strings that are used as a backing store for the buffer to change. And when that changes, in order for that change to be rendered, that's another task that gets run. And that task takes the vec of strings and then turns it into a byte array, gives it to a nom parser to turn it into an abstract syntax tree, which is then used for syntax highlighting. That's a lot of words. So essentially, the Markdown document, like you can think of it as a document object model. The Markdown text is the raw text, so to speak, is stored in a vec of string, where each string corresponds to a line. Then that has to be turned into an abstract syntax tree, which is then given to, let's say, I have a syntax highlighter as well for this abstract syntax tree, which is custom. So essentially, turning the Markdown into a token tree, which is the abstract syntax tree. So things like fenced code block or heading or a bulleted list or whatever it is, those are all like elements in this, or tokens in this token tree. And the parser, which is written in nom, actually does that. Then whatever token tree I get, I end up syntax highlighting and then sending it to a renderer to actually then print to the screen. We're not talking about that. So just kind of like focusing in on that Markdown renderer part. That's where this video is about. So I have to convert a vec of string into a byte array every single time that a person types something into the editor, which is really slow because, as you know from my previous video on memory latency, the vec of strings is not that great of a data structure in the first place to be going byte by byte because of the multiple pointer dereferences, and on top of that, allocating an array either on the stack or the heap of the size of the vec, total size of the vec of strings, like how many U8s are actually contained in it. That's expensive. Then copying every single line into the byte array and then adding \n, that's also expensive. So the sort of fundamental problem here is that my editor buffer uses vec of string to represent a bunch of lines of text in a buffer, and nom wants everything sort of as a slice. So it doesn't want the vec of strings, it just wants a slice of essentially an array of strings or something along those lines. Where that's not even true. It actually wants like a full byte array, and in that byte array, every line is, let's say you take one line in the buffer, you copy it to the byte array, then you append \n, take the second line, then you copy it to the end of the byte array, and then you add another \n and so on. So that's expensive because it's a lot of mem copies. So just to construct the byte array, which has carriage return line feeds in it, anytime there's like, essentially it's taking the vec of strings, and every time a string ends, it injects a \n into the byte array, and then it takes the next item in the vec of strings and then injects that in the byte array. So it's really slow. And so this particular video will talk about if you have your input, which is of a let's say a collection of own types, then how would you go about it? And in order to kind of work up to that, we'll talk about how nom itself is put together, how it's intended to be used with slices, what the nom : input trait is, how does slices work with how do you create sub-slices from slices, and then eventually at the end of the video, in the live coding part, I'll actually give an example of how we can create a parser that does work with let's say a collection or a vec of own types like string. So with that, let's get started with the live coding section of the video. So let's create a new project. Let's see, there we go. Let's say new, let's just say yeah, that's it. And then let's use, okay, so let's get rid of these. And let's do this one. So let's step out our first example. So let's see, we can do something like let's say mod example 0.0, because we're gonna have, so this first example, before going into nom, I just wanted to spend a little bit of time on slices and how that works. So let's say that we have a function. So let's do this. Say mod tests, and here we say something like this is test use split first. So let's say that we have so the way nom does what it does is that you give it an input, and it will try and parse it, and whatever, and the input is going to be a slice of string, string slice, or a slice of U8s, and then it'll apply some kind of pattern matching. It'll take whatever bytes or chars it needs, and then it will turn those into something that it outputs, a type that it outputs, and whatever it doesn't consume or take, it will leave as a remainder and also return it. When as the return, it's a tuple that gets returned, actually both these items, once your parser finishes executing. So that's generally the pattern. There's going to be an input, which is a some kind of a slice of bytes or chars, U8s or chars, or it's going to be something regardless, whatever the input type is, the remainder is going to be that. So generally that's how this works, because this is the remainder of what part of the input did not get taken, and then this is the parts of the input that did get taken, and then they got turned into this return type. So that's how roughly the parser signature is in basically all of the non-parsers. So there's a couple of advantages of doing this, because this ensures that like no allocation, well, that's not entirely true, but more than likely no allocation is happening, at least when you're taking parts of the input. So, but how does that work? If it's a slice and you're returning a remainder, how does it not allocate? Like, what is happening? Like, I give it, because a slice is a view into something. It's a read-only view. So how can we, how can we split, or how can we get a remainder from a slice, from an input slice? So in order to do this, let's look at the actual slice. What is this? The slice, actually, let me see. I think it's trying to slice. I think it's called split first. Yeah. So this is in primitive type slice. Okay, so this is just in the standard library primitive slice. You have something called split first. So yeah, it's in the slice module. So returns the first, and so how does this work? So this example, I'll use it, and in the next example, or the next test in this example, I'll actually show how to write it. So this one will say fn create or write function to implement split, or something along these lines. Okay, so let's make a slice. Actually, it's not a set. Let's make an array. So this is going to be an owned type. We're going to say 1, 2, 3. I mean, this can be like this, ABC, it doesn't really matter. And then let's say that we want a slice that represents the full span of this vec of strings, right? So the one we can use ranges. So we can say slice equals, and we can say owned a slice. That's one way. That'll basically allow us to access this owned type as if it's a slice, or we can say, this is another way. It's the same thing basically. So here we're saying give me a range from like 0 to like owned, something like this, and then you don't have to type all that. So you don't even have to type all this. You can just say like you can say owned as slice. But for educational purposes, this kind of, I just wanted to show all the sort of like all the different ways in which you could do this. And then finally, let's say we wanted to get the first item out of owned. So actually, no, that's not true. We want to get the first item out of slice. So what we can say is so slice dot split first. And what this does, somebody use let it. So what exactly does it return? An option with, looks like option with a tuple. So we can say maybe, and this is a tuple. And so here we can say, so maybe tuple, right? So we say, actually, let's do this. Let's do this. So the maybe tuple is going to be, think of it this way, sum, and it's going to have another tuple, which is the first and the rest. And then, there we go, and then we can put an else. And here we can say, just panic. So here, if we examine this code real quick, so what this means is that the split first method on the slice gets the first item in the slice and returns that as the first item of the tuple. Then it creates another slice with the remaining items and then returns that as the second item in the tuple. So that's the first and the rest. So here we can make some assertions. We can say assert that first is A, and I think this one actually, why is oh, yikes, I shouldn't have called this slice. Let's call this owned slice, something like that. And then I think if we get rid of this, and then what's the problem here? Oh, I see. I see. Oh, okay. So essentially, should probably, how do you make it, how do you add the type? Yeah, let's do this. And this is static because actually, because it's allocated here. I don't know. This is, do we even need this? Yeah, that's what I thought. Okay. So here we have essentially, we're taking the vec and we are saying that, okay, I want to access this vec as a slice. That means I will no longer be able to, the capacity is dropped. So this slice pointer, this pointer has three things: the pointer to where the memory begins, the capacity, and the length. When we turn it into a slice, we drop the capacity, and we have a pointer now that gives us where the you know, this slice begins and how many items are in it. What's the length, but not the capacity. So here we can say something like assert the slice length is 3. So here the reason this isn't working is because we just need to, it's a pointer. Okay, so now this should, let's see, this should run, yeah. So no surprise there. So okay, so how exactly did, that's great that this worked, but how did it work? So what if we were going to write a function that did actually this split first thing? So what would that look like? Well, we would definitely take a slice. Actually, you know what? I'm just going to rename this slice. There's a slice module. That's why I renamed it to slice of owned, but let's just do slice because we're not really using that module. Let's see. And I think split first. Yeah, this is. Yeah, this is the slice module, and that's one of the methods of a slice. And this is a slice, so it inherits this. Not inherits it. This is implemented for these kinds of types in the standard library. Okay, so let's see. So here what we can do is that the signature of this function is going to be something along this lines. Split's going to be split first. So T is the type of the slice. This is the slice, of course. And it's going to be optional because if my slice doesn't have any length, right? If it has nothing in it, if it's empty, then it's going to return none. So that's why we say option. But if it does have stuff in it, then it's going to be a pointer to T, and essentially it's going to be a reference of T, which is going to be the first item in the slice, basically. So actually, let me see. think pointer, oh sorry, a slice of type T, and this is going to be a reference to T, and that's going to be the slice itself. Okay, that makes sense. So this is a reference to T. That's not T, because we'll see why in a minute. So because this is also a reference to T, where T is this thing. So that's why it's ampersand stir. That's why we had to put an ampersand here. I guess we could have done this. Oops, what is happening? We could have done this. Whatever is easier to read. So here, what we could do is, okay. So if the slice is empty, then we return none. Otherwise, what we can do is, this makes sense because, you know, whatever, the slice is empty, so it should be none. So let's run this real quick. So we can say split first. So let's do our test case, owned. And this time, because, you know, last time we used this syntax, let's use a different syntax. The same thing. It's just owned slice. Same thing. It should be 3, and then here we can say, let's see. Actually, let's do this none example first. So let's do something like this. We say the none case, none, and this is some. So in the none case, we will say let owned equals empty vec, slice is whatever that is, and we can say that, and it should be none. So we can say assert result is none. So this should work. So let's see if this works or not. Yes, so that's great. That was not that interesting. So here's the interesting part. So what is the first? Well, the first is going to be, we're going to take the slice and we're going to get the 0th element out of it, and then that's going to be of type T. So this is actually moving it out of the slice. It's up to us. If we had said like this, then we can say something like first, and here we can say rest is, let's just do this. Aha. There you go. This is why it's a reference, because remember slice is read-only, so we cannot move out of the slice. So this has to be an ampersand T. That's why we had to do this, because a slice is a read-only view, but we can create as many read-only views into the like we can make a smaller view, because slices are sequential. Like they're not essentially. If you think about it, like, where's this? Oh, contiguous, yeah. So slices are contiguous in nature. So what that means is that if I have a bigger slice, I can get a smaller slice out of it. But if I have 2 chunks of a bigger slice, I cannot like stitch them together to give you a 3rd slice. That's not good. So then allocation is necessary. So I'll show that in a minute. So here we have a tuple. We can't do this. This is, and then what is this? Let's do this rest. And then it's an option, so we have to say something along these, or we can also say like into. That does the same thing. But whatever. The point is, there's a first and a rest, and so if you look at this, what this is doing is it's grabbing. It's just so we get better. Actually, let's do this. Let's write it up. Tuple, and here we have tuple. Yeah, something along these lines. So this one. Actually, see, this is gonna break because no, you can't do that. Which tracks, that makes sense. And here we have to say ampersand. Okay, So here we have the first item, which makes sense. We get a reference to the 0th item in the slice, and then which is just one item. It's not a slice, it's just a reference to that type. But this one is the rest of the slice. So then we say, remember we had the syntax where you can say 0 and then like 3 or whatever, and then whatever, whatever that is. So you can say owned. So you can do it like that, or whatever. You can just put it like this. So what this does is that it's just saying give me a slice with the first item dropped. So the rest of the slice. So it's a sub slice into this larger slice of ABC. So ABC in this case is the full slice, and then we're going to get a sub slice. So we can say something like result, we split first, that's this function that we just wrote. And then we should get assert, yes, it's some. Actually, we can just say assert equals, let's see. Oh, what does it say? Ampersand, found tuple. Oh, I see. This is not a slice. Okay. Oops. So what we could do is something. You know what? Let's do this. Let's say first stress. Yeah, exactly. So assert, that's A. Rest is B. Yeah, and so this is much easier to read. So here we go. So we have essentially, this is some first rest, and that's just none. So here, let's see, result split first. Okay, so here, actually we don't need this. Yeah, okay. So the split first grabs the first item from the slice, then returns that just as a reference to the type T, and then it gets a subslice, because that's what this is, a range operator. So it basically gets a subslice of the original slice and returns that in rest. So we've seen now here, given a slice, I can make you another slice. But what I can't do is stitch together, like the slice that I get is, I can't, it's not mutable. So once I get a slice, like I cannot get a slice out of let's say this is our, actually let's call this our slice in this. So let's call this our slice argument, and this one is our, you can almost think this way, it's like slice remainder. So so given the range operators, because they have to be contiguous, I can't say like give me like, let's say that the input is longer. I can't just say something like give me the first 2 items from slice arg, combine it with the last 2 items from slice arg, and return it to me as a slice. That's not going to work, because these are 2 separate locations in memory, and they have to be contiguous. So I can't just combine disparate ranges, cherry pick them, and then return a slice. That because the slice is read only, so I can't do that. So, which is pretty cool. And so the only way to do that is I'd have to allocate. And in that case, if I wanted to allocate, because that's what my parser logic dictated or whatever, then this type wouldn't be a slice. This would be an owned type, so to speak, like a vec of t or something. Oops, something like that. Yikes, vec of t or something along these lines. So, but it isn't in this case, so we're gonna leave it like it is. So yeah, that actually is a rather long walkthrough of how like take works under the hood, and take is a part of the input trait, which we'll look at in nom. And if you look at, where's the input trait? There it is. I think it's like take is here. Yeah, there you go. So that's kind of like returns a slice of index bytes, blah, 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 whatever. But basically, this is the input trait of nom, which essentially is if you, it's already implemented for ampersand stir and ampersand like angle brackets U8. So if you wanted to implement this for whatever type, and I have an example that I'll do where I'll implement this for a vec of string, and so we can see how all that works. But roughly, this is the sort of the root of how all of this works. There's a parser. The parser takes an input. The input is a slice of type t, and then it will match against some logic, and it will split whatever it's matching. That it could be of type t, or it could be a slice of t, and it will separate that from the rest. It'll take the first bit that it matched against, and then it will transform it into a different type and return that. We're not seeing this here because this is like just part of the parser logic, not the whole thing. So yeah, with that, like that's a super duper deep dive into like how slices kind of work with the parsing, with the parser, non-parser, and it's kind of like the foundation of how like nom is really optimized to work with slices. So one thing in nom, before I jump to the next example, is let's see, oh yeah, streaming versus iterator. So there's a complete functions in nom, and there's also streaming functions in nom. These match input, or different types of patterns in the input. So streaming specifically is for when you're loading the bytes that the input has from like a network or something. And because one of the things that a streaming parser returns, there's a it's like it needs more bytes basically. So with complete, the difference between streaming and complete is that with a complete parser, all the bytes are already in memory before you call the parse function. And you can actually use an iterator. Like let's say you have some type and it gives you an iterator, and that iterator is not streaming, even though it has a next, because that iterator, whatever it's iterating over, let's say, assuming you're not going over the network, but let's say that you have an iterator from some vec or something, you can always collect it and then pass that to the parsing function. But the point is that when you're collecting it, the next, that call that you're making is going to hit memory, not network. So that's the difference between a streaming and a complete parser, and iterator doesn't necessarily mean streaming parser. You can have a complete parser that uses iterator, and I have an example of that as well. So yeah, and then let's see, it's kind of like peeling the layers of the onions of nom. So as you can see, this is a slice-based design, so we everything is slices that go in. We even noticed that was split first because we actually implemented from scratch. This implies zero copy parsing because I'm just dealing with slices, but that doesn't mean like there's no latency to access, right? Like if I have essentially a pointer to a slice, I still have to dereference the pointer to get to that memory. There's still a cost to accessing that memory. It just means that there isn't a cost to of memcopy, because I'm not necessarily allocating another buffer in memory, another array in memory or whatever, and then copying items from my input to that other array. That's what this means. Not that it's zero latency or anything like that. There is still memory access. You still have to dereference the slices because they're pointers to contiguous chunks of memory. That's what a slice is, with given length or whatever and a type. So yeah, and we'll deep dive into the input trait. I already talked about the streaming versus complete. Yeah, and we can talk about this later as well. So this just means that when you combine parsers and you can, because it's functional programming, you can chain like if then else statements and while statements. You have to there's combinator functions which implement that, and what that means is that if it goes down a particular path and the parser fails, it won't take the input and it will return, so that the combinator can then continue in a predictable manner. So we'll see examples of this as well, actually, in this. Yeah. So there you go. So this that was the kind of like under the hood, like deep dive string slices and split first and how slices work and that kind of thing. So the next example, let's see. The next example is going to be, let's actually implement the input type on a vec of string and see what that looks like. So now let's implement the nom input trait on an own type, which is a vec of strings, and then let's see what that looks like. So to get started, let's do this. Oops, yep, that's the one. Let's make a new one of those, and then here, actually, we can't implement input on a vec of strings, so we have to make a new type. So if you haven't seen this before, you can check out my new type video. It goes all over how to use the new type pattern. So we're going to do pub struct, let's say owned strings, plural, and here we're going to say pub vec string. And for testing reasons, we're going to do derive. Oops. Sure. Okay. So that's great. Now we have our OwnedStrings struct. So we're going to have like a whole implementation of the, we're going to do something like this. Let's see, mod impl input OwnedStrings, like that, where something along these lines. This is to do. And then what we can do is let's write out like what we expect this code should do, right? So let's say we do mod cfg test. Okay, so we're going to say something like parse hex color. So one of the things we want to do is let's write out the test cases for what we want to happen. We want to have, so the input is going to be in the form of a vec of strings. And the output we want to be a tuple of U8s. We want to parse those strings as hex values. So we can say something like let input owned equals, oops, no. We can say something like 2f14, there's a df, there's like some example. This one basically. It pretty much shows how to do it here. So here we have, and again, I'm not showing you how to make a hex code color parser or whatever, but it's a different type of input. It's an owned type. So what to do when you want to parse an owned type? Like what are the semantics of implementing the input trait? Like what does take mean? Actually, let's before we get too far, let's look at what take actually means, just generally speaking, just so we have like an understanding. So let's say we have nom take for string slice. So it's kind of like what we'll do here is that we'll take 2f, we'll take 1 we'll take df. For each one of these that we take, we're going to use this U8 from stir radix input string and just convert it to a bunch of U8. So there's not a whole lot going on here, but it's just to show like implementing input for this struct and also demonstrating like what take means. So let's do this. Let's say our input was this is a different example, right? So it's like A, B, C, D, E, F, something like that. And let's say we say something like take. So we say take. What are we taking? Say take 3 items from input. We need to input take. So we say nom byte stick, and here we say let it equal whatever, something like that. And why is this complaining? Expected function. Is that not bytes? Nom bytes is complete. Oh, interesting. There's a take and a complete take. Fascinating. Okay, so this is the one we want, the complete. So here it's complaining. It doesn't know what the type of 3 is, so it can handle U8. So let's just do U8. Now what's the problem? Type annotations needed. Oh, I see. So this is going to be I result, which probably needs to be imported, of string slice, because that's what's, you know, going in and coming out. This is the remainder, basically. And this is the output. So this parser doesn't do much. It just basically takes three chunks out of this input, whatever those chunks mean and whatever take means. So what it is we say something like the remainder should be DEF and the output should be ABC, basically, is what it should be. Let's see if this works. Yes. So hopefully that makes sense. So it's like this is the, I don't know, result, but whatever, the output result. So the output result contains the remainder and the output type. So that's what take does here. It just takes like three items. So what is the equivalent of take for this? Because we're gonna have to take this, and this, but obviously it's not the same as the meaning of it you know, for a string slice. So this is for string slice, the meaning of take is quite different than what we have here. So that's kind of like what we have to think about. So because in writing this parser, we just have to like take 3 items from this OwnedStrings, convert each one of those items into essentially a U8, and then return the tuple, and then whatever remainder's left. So here we can say something like input owned is this. So let's look at the expected output. Expected output is going to be a tuple of, that's right, 2f whatever that is, and we're going to do output result. Let's see, output result. Let's see. This is going to be the thing that, let's see, expected output result. This is going to be the thing that our parse function actually generates, but we are going to give it the input. We're just going to move the input owned into there. And then we're going to say let remainder, oops, remainder, and then whatever tuple is going to be output result unwrap, and then we're going to say assert equal remainder is an empty vec and tuple is expected output. That's exactly right, I think. Actually, let's see, is that going to be an empty vec? Let's see, assert equal, I think so, should be an empty vec. Interesting. So what is the type of this thing? Remainder. Let's see if this works. Let's see. So remainder. I think the type of this is remainder is, I think, like a string, and the tuple is a bunch of U8s. I think that should do, yeah, okay, that handled the type and so it's basically we can do that here or there, but whatever. I decided to do it here. Okay. All right. So far so good. Now what we can do is we can ask. We can say something like implement the what is this thing called? implement the nom input trait for OwnedStrings using nom 8.0. Then for the selection, make sure the generated code works for the given for this test. Yeah. So okay. So essentially, oh, and also we also have to tell it to implement Parse hex color, which takes a vec of string as input and parses each item in the input vec as a hex value. So basically u8 from string radix, something like whatever, chunk and then 16, something like that. And there can only be 3 items in the input vec. In other words, the owned strings, basically. Owned string 0. Okay, so I think that's right. So implement the input trait so that we know what take does for owned strings. Make sure that this whatever code works with this test, and obviously write the this one, the function, the main parser function, which takes the owned as input and parses each item in the vec as a hex value. They can make 3 items. Okay. So hopefully this is enough information in the prompt. So it's really 2 things. It needs to generate what the heck is it doing? Implement lifecycle. Interesting. Let's see what it's doing. Okay. So what? Input. I don't think this is right, because the input, what the heck did it do? Okay. And nom input for OwnedStrings using nom 8. Okay, let's not use Cloud. Let's use Gemini. I don't think that was right. Okay, let's see if this works. Can you show me the implementation? Oh. No, that's not right. Okay. Let's try this. Boy, that didn't work. I should have saved the prompt. Let's see, Gemini 2.0 Flash. Let's try. Heck, let's try GPT-4. So we can say, let's have it do the same thing again. Okay, let's see if this works. Oh no, this is using input take, which is not right. Please don't use input take and use nom input only from nom 8.0.0, which you can get from here. Yeah, because input take is how it used to happen in nom 7. Okay, input length for OwnedStrings. Why is it saying input length? input iter for OwnedStrings? Slice? What? Nope. No. What? What is it? Input iter or slice? Just nom input strings, so that the let's see. Buffer. No, it's gone. It's gone somewhere else. This is not right. Ugh. Okay. Oh, this is on it? Okay. Nope, this is, I don't know where it's getting this EOF and all that stuff, because that, oh, take, yeah, that's right. Where are you getting EOF? There's no EOF. Okay, all right. Position, split at, needed unknown. No, this isn't right. Okay. Let's start it again. All right, let's use this one. Let's see what we say. Based on, actually, is this the correct selection even? Okay, based on selection test, please generate a function. Okay, next string. Okay. Also, don't implement slice, or what else did it implement? Input take. This is the old way of using nom7. Did I tell it to use nom? Maybe that's the, oh, I did, yeah. Okay. Let's see if this works. If not, I'll just write it by hand. Oh boy. Okay. Cloud Sonnet 4. I wonder if that's better. Let's try this. Huh. Sure. Okay. Since you want to invest, okay. Sounds better. Let's see. Parse hex color uses take. So it takes three things and then parse. Okay, this looks promising. Input take. I did input take. But there is no input take. Why is it? Okay, let's copy this here for now. And then we'll come back to, actually, is this the whole thing? No. What the heck? Input take. And it's implementing slice. I don't need slice. What is it doing? Actually, this is the only thing I can use. Basically. Why? Let's see if I can fix all the imports here. All the nom ones, let's say take Huh? Oh, right, because you cannot take 3 from our input type because I haven't, is that already? Oh, wow, okay, cool. I haven't actually implemented the input type for this, so I'll give this one more chance and then I'll just do it by hand. Sorry, that is incorrect. I meant the, what file is this? ex01. Implement the nom input trait for owned strings using nom 8.0.0. All right, if this fails, I'm going to do it by hand. This is, you're right. I need template. Yes, yes, you are correct. Hey, this looks promising. Okay. Let's see if I can just do this. Okay, so this is gonna should resolve this take. What the heck was that? Set to copy. Why does copy not work? This is weird. Okay, so implement input. Oh, let's see. Iter item self iter indices. Iter indices, iter elements, self iter. Iter is self item. Actually, self item. This should be item. Can I fix it? Let's see if this works. Iter indices. What? Iter indices is used where? Self zero length. Standard ops range. That's not right. So expected range usize to be an iterator that yields usize string, but it yields usize because this returns. Yeah, I don't think that's right. I think iter indices is supposed to be something like iterator that yields usize, that yields. So this one yields. Iter indices, usize, and self item. Is it like this? Oh, I don't think so. Oh, oh, that was a range. Ew. Okay, what's the problem here? Expected range usize to be an iterator that yields usize string, but it yields usize. But okay, let's see if we can use tuples instead of just usize. So custom iterator pairs indices with the corresponding strings. Huh. What do you know? Okay, that's cool. All right, so input is implemented for OwnedStrings, and we have take, I think, in here somewhere. That's the important one. Yep. Then we use take. What's the problem here now? Expected value. Oh, right, 3. Oops. Take u8. That's okay. So it goes, all right. So go. So it says take 3 hex strings out of the container, or whatever the collection, the input, and the remainder should be hex strings. This is the what is the type of this thing? OwnedStrings. Oh, okay. So here we can assert that the hex strings, and then we can say assert equals. Actually, that's what would the I guess we could make an assertion for what that is in. Oh, what's wrong with this now? Oh, OwnedStrings. Yep. Okay. Good catch. Oops. It's strings. Oops. What's the problem here? Output result. I thought this returns OwnedStrings. So what is it saying? I think it's as vecstring. Yeah, okay. All right. I mean, it's a macro. That's why. I guess here we could still have a. What is this? Something like, I don't know. I don't know which one is easier to read. So I think, let's see, will this work? Yes, it does. All right. So net having implement this, let's see what happened in that whirlwind. So take, we went over what take does, and then we wanted to implement take for OwnedStrings, which is what this entire journey has been, is implementing the input trait for OwnedStrings. And the key one is here, right here. So it goes like take basically. I think there might be an easier way to do this. Self 0. I can just say. I think we can just say. Let's see. Self 0. So what we're doing is we're taking the. Let's see, 0 to count. So we're taking. Up to count and vec. Is that right? Let's say explain this. Accessing a slice of data. Dot count. This is it creates a range from the beginning of the collection up to, but not including. So essentially, take up to but not including, because it's like 0 dot dot. So whatever. So basically, it takes the first up to count items, and then because it has to be owned, we put like 2vec, something like that. So I think this is a bit easier to read. Okay. Let's see. Iterate elements. This is that's fine. I think these are the helpers for the. This is helper for. I think it was. Actually, what is this a helper for? Nobody uses it. Oh, iter elements, colon into iter. Actually, I forgot which one was a helper. Anyway, so iter elements, iter indices. Just clean this up a little bit. Okay. And then these we can put up here. Iter elements, iter indices, position, slice index, take. This is the big one. And then there's like take from. Actually, this is like very similar to this, but like we just say like let's say, yeah, like that. So this means like take from like the whatever's left over, basically the so starting from count index and extending to the end of the array. So from count until the end. So take from count until the to the end. So it's kind of like dot dot count and count dot dot. So okay. And then take split. Let's see, self take from. Oh, that's actually pretty elegant. That's cool. Does this work? Let's see. Yes, it does. Wow, I like that. It's cool. So essentially, take split. That was like the what is it? We did like a implementation of let's see. I think it was like split or something. Let me see if I can split first, kind of like that. Okay. So take split, and then yeah. So essentially, what does it do? Not enough input. It actually take will also air out, so I don't even know if this is necessary. Yep, it is not necessary because take, you know, will barf if parse hex color is the main parser, so this should probably be. Oh, actually, that's all we got. That's great. And then yeah, so take 3, and then do this. Okay. Parse hex color. Let's see. This is actually pretty straightforward. Yeah, so basically the magic was implementing take for OwnedStrings. That's what took so long. And then that essentially comes as a bunch of hex strings. Actually, we can do an assertion here. I mean, it's kind of like pointless, but I mean, if we wanted to, we could say, yeah, we have 3. We know that because, you know, this would have not worked otherwise. And then I think, yeah, and there's no remainder left because we've consumed, you know, all 3 items in the OwnedStrings struct. So yeah, with that, I think that finishes the input implementation, and then we'll do the next example. I think, what's the next example? Oh, I think we can do like a more complicated parser implementation, basically, where yeah, where we instead of implementing, it's not more complex, actually less complicated. It's like instead of implementing input, we can convert the own type to slices. I think that's the next one. So we're going to convert the own type to slices instead of taking the you know, the effort of implementing input on OwnedStrings. So it'll be OwnedStrings to some slice variant of OwnedStrings, and then write a parser to do this. Yeah, cool. Before moving on to the next example, I actually just wanted to clean up a few things in this color. So one thing is that, so the take function this takes like 3 items basically, 3 items, and the what it returns is, you can think of it this way, it's like let's see if this works. It returned tuple owned string like that. Actually, let's do this, and then we can do something along these lines. So, oops, owned strings. Okay, so that, yeah, that gives the essentially the remainder in the, well, it's not hex strings. It's like it's kind of like hex string. Well, it is hex strings. Okay, fine. That's not a bad word. Okay, so we know that the length of the hex string should be 3, and for sure, but we don't know what how many chunks are going to be in the remainder. So, and the chunks are each chunk. So I guess we can do this. We can say let RGB chunk. Oh no, let's see. R red chunk equals. Let's see. We can do something like this. So hex strings dot 0. This is to get to the underlying vec. So we can say underlying vec is that, and then we can say underlying vec. Let's just grab 0. Okay. And we can do as string, or we can just put reference. Either way, it should work. And then here we can say green chunk, blue chunk. And then if these array accessors, and we know that the array accessors will be fine because you could even do this debug assert. This just essentially, yeah. What's going on here? Debug assert. Okay. So red chunk, so underlying vec, and then I don't know if chunk is whatever, like the red item in that underlying vec, the green item, and the blue item, something like that. And then here we can say, where's the uwait from string radix? So here we can do something like, let's say we could say match, and we can say something like match the, oops, no. So let's say we're going to say parse the red item, parse the green item, parse the blue item, and let's say we have like an OK variant, then we can return, like, let's say GB, then here we can say something like, well, this goes away because I'm trying to like, so here we can say return like so. There we go. I think this is a little bit readable, more readable. So we have the underlying vec. Actually, let's see if this works. Let's see. No, it did not work. Parse hex color. Index out of bounds. The length is 3, but the index is 3. Oops, how did that happen? We can also get an iterator from this, so we can say iterator, and we can say iterator for vec, and then we can just do like next, something like that. Then we're gonna do an unwrap because that'll give us the. You can do it like this. I mean, we shouldn't be using unwrap, but I mean, this is made up, so we can do something like this, so like that, and that should work. No. What's the problem? Oh, needs to be mutable. No. Oh, consider changing this to. Oh, 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 oh. Okay, so next unwrap, this should work. Yes. I don't know, this way we got rid of the index thing. So anyway, but we know that we can call it 3 times. We've already asserted that there's 3 items in it. So, and then, actually, you know what we should do? We don't even need this. This is just confusing because we know that it's gonna, we know that take will take care of it, so there's no point in it. This is just like completely unnecessary. We could also like, you know, the red item, we can do something like this. Like, I don't know if we need to, we could put this here. I'm not really sure what's more or less readable at this point, but I think I'm gonna stop here. So this is good. So now we're like, we have a clear sense of, you know, what's going on. Let me make sure this test runs. Okay, perfect. So, all right, with that, we will now, let me make sure this works. Yep, that makes sense. So yeah, that was a lot on input implementations for OwnedStrings. And the next one, we're going to sort of not do this, and we're going to see how far we can get by converting the own type to slices. Okay. So in the next example, let's do a borrowed strings version. So essentially, we implemented input for OwnedStrings, and then we saw how the take built-in parser from nom works with it, because it allows nom to understand how it can manipulate our data structure, you know, in a way for parsing. So it can, you know, take, split, and so on. It can iterate over elements and figure out how to determine how to index into this data structure, because nom has no idea. We have to tell it. So this is just one example where essentially a vec of strings, each item in that data structure is a string. So it's mimicking a vec of strings, which represents like lines that you type into a text editor, where each line is a string and the vec of strings is the buffer. So in the next example, we're going to do a borrowed version of that. So essentially, because with nom, like we could just use a string slice or ampersand, a slice of U8s, but instead, what if we just implemented, let's say, the input trait for the equivalent of a vec of strings. So it would look something along the lines of, we can call this thing, because we know it's going to be, we're going to have a borrow. So we're going to say the struct is a stir slice array. So actually, let me expand this name so it's not so small. Stir slice array. So the data structure is a stir slice array. Actually, before I make the data structure, let's look at how I even came up with this type. So if we have something like this, just whatever, just an empty test. So here we're going to do something like this. We're going to say so we have like, you know, something like, let's say line 1, line 2, line 3, perfect. And then now we have, let's say, borrow of this, which is obviously owned. So we can do something like that. And then that's a slice into the vec of string. So the data structure that we end up coming up with is something like a slice of string. So let's do another like version of this. So instead of, so that's one. So let's say just to kind of, let's do another one where we say test2 where we have, let's say we have an input, which is, oops, what the heck, let input equals, we have something like this, 14 and D, yeah. So actually no character line feed, I think at the end. So we have a string, which is delimited, three strings, which are delimited by a character line feed, or new line character. So here, if we were to do this, we say, so that's our, actually let's do this, let's say this is our lines. So, because this is the vec of string, let's say. So if we say lines vec, we can do something like lines dot lines that, this is a thing that you can do, and now we'll get a vec of stir, let's say, and then let's see, where's this other one? So let's see what type this is. So we got, so lines vec is a vec of stirs. Now if we do let the slice of this, so we go, actually either we can do this or we can just say like as slice, then that's the type we get. So this is the data structure that we're actually going to be using as this one. This is just like to show, you know, whatever. Like this is a slice of string, and this is a slice of %str. So it's a string of, it's a slice of string slices. So this is slice of string slices. So we're basically basing the data structure on this one, not that one. This is don't use, and then this one is use this as model. Okay, so now given that we have the sort of starting point for this, let's make a pub struct. It's not going to be owned. It's not going to be owned. This is going to be a string slice array. It's you can say a slice of string slices. You can say slice of string slices. That also works. But I don't know. I'm not really sure which is a better name. Let's see. Derive. So let's see. Oops. What is happening here? Oops. What the heck? What is this? What is the problem? Oh, geez. Okay. So there we go. So we can say slice of string slices, SS, whatever. That's a long name. Actually, I don't know. Slice of string slices. Slice of string versus like string slice array. So I kind of took string slice, that meaning that this is the string slice, and then array meaning like it's a slice of those. So I don't know. I guess I'll keep this in the comments, but I'm not really sure. AKA, so we can do something like this. Oops. And let's call this string slice array. That kind of helps me understand it a little bit, but whatever. So this is the string slice, and this is the array part. So, okay, anyway. So naming can be difficult. So so here we have like a type that essentially is a borrow, is a slice, and inside of that slice are a bunch of string slices. It's a slice of slices, which maps to this slice of slices. So basically this is a slice, this is a slice. Actually, let's just print this, and then we can see what the heck I'm talking about. Print line, oops, Yeah, this one. Let's see what this looks like. So let's do a debug. This one. Okay. So you can see like there's the, let's do this. So if we wanted to make a documentation for this, we could say something along the lines of, this is the array, and each one of these is the string slice, basically. So we have, yeah, so essentially the array part is this enclosing thing, and the thing in the inside is the string slices. So here we have, like, for example, assert equals, of course, and then we can say assert lines vec slice 0 is 2f because this is a string slice, and this is the 0th element. So here we can say 0, 1, and 2, something like that, basically. Yeah, there we go. So our array is this thing, and the string slices are in there. So these are the, you can just say slices. Oops, array, and these are the string slices. Okay, so then we can say the second was 14, and the last one is D. So this should work. Excellent. All right, so so that's the deep dive into, like, okay, why the heck is this called this? So another way to visualize this, and I actually did this earlier, is this picture. So we have, like, this is the array thing. So we can say this is the array, and here this is the oh, actually, sorry, this is the reference to the, let me think, actually it's the same thing. It's like this is the reference to a slice of string slices. Oh, okay, this one is a slice. This is, it's kind of like if you dereference this, you would get this angle brackets thing. It's kind of made up. This diagram is made up. It's not real. But it's meant to depict, like, okay, each one of these things. So I guess you can say reference. This name is getting weirder and weirder. Maybe it should just be slice of string slice. You know what? I'm just going to make it slice of string slices, because this is the reference to the slice of string slices. Then this is the array of string slices, which is the same thing. Let's say, and then here we have the string slice. So, slice of string slices. Sure. I mean, technically that is the array, so maybe it's array of string slices. I guess when you say a reference to array of string slices, then this can be turned into slice of string slices. Sure, why not? Because the slice is it's an array. It's a pointer to the start of an array with a length that's known but no capacity, because you can't mutate it. Okay, fine. I might change it later, but let's just go with this. So maybe we could say AKA string slice array. The reference to maybe like reference, something like that. String slice array reference. That's terrible. But okay, let's do this. So string slice array reference. String slice array reference. String slice of string slices. I'm liking slice of string slices more. You know what? I am just going to go with this then. This sounds good to me. Let's do let's see, this is for the GitHub repo. I'm updating the slice array ref. We're going to replace it with slice of string slices. Okay, that makes sense. That makes sense. I mean, it's a bit awkward, but it's all awkward. All right. It used to be, I was thinking about it more like string slice array, but I like string slice. I like the call it what it is kind of approach, even though it's a little bit verbose, but whatever. Okay. See if that works. Yes, it does. All right. So let's see this. So we have the array. Well, this is not array anymore. Now it's like the slice, and this is the slice of string slices. Okay. You know what? I like this the most now. So we can put this here. Something like that. I wonder if tell it this is Rust. That's not Rust. Okay. That's just, this is JSON? Nope. JavaScript. Anyway. Let's just call it text. So okay. String slice array reference. So yeah. Okay. So I am updating. I have a GitHub repo for this, so I am actually updating that in the GitHub repo right now. So okay. So now that we're deeply familiar with the slice of string slices, let's implement the nom input for it, and then we can use it basically. So essentially, like once we have one of these that we pass to, actually let's do this. Let's do fn test use slice of string slices. So here we can just take this whole thing, and then we can just say let slice of string slices is that, and that should just compile. Okay, great. And then actually let's invert let's put the most relevant stuff on the top and the least relevant stuff on the bottom. Okay, so and then we can say something like this. Yeah, length is 3. Excellent. All right, so now we have a syntax. So what we really want to do is we want to do this. We want to say something like test. So use slice of string slices with a nom complete take. Okay. So this is where nom doesn't know about our data structure. So if we implement the nom input on it, we did so in the last one, last example, but that was for an owned type. This is a borrowed type. So what would that look like? What's going on with these brackets? Okay, so here we can say just the same thing. We basically collect. Oh, actually, yeah, something like that. So we say we use the nom bytes complete, the stake parser, and then we say, okay, here's the lengths. It's a, I wonder why D, I thought it was DF or something, whatever. So actually this is supposed to be DF because I don't know what happened. That's weird. It's like whack-a-mole. Where else did I mess it up? Okay, that should, if we take this out, that should work. Well, let's see if this runs. Okay, great. All right, so what we want is we want to use the take parser, and we want to take 3. items from it, and we want to give it the string of slices, not .0. We want to, I don't know what the heck is happening here, but okay, so I want to give it the string of slices, which is our data structure that we made that's borrowed essentially. And then we want to be able to do stuff like from make a string, call lines on it, and then call collect to get a vec of string slices. Then we convert the vec into the outer slice, and then inside of that outer slice we have each item is itself a string slice. Whew. Saying slice a lot. Okay, so I don't know why this is saying 2. Okay, so and then we can say something like this is the remainder, and this is the output. And I think let's see. I think that should work. Yeah. We might have some type errors to deal with later, but whatever. This is the signature that I'm looking for, and then we can say something like assert eq. The remainder should be well, the remainder 0 should be nothing, and the output 0 should be, oops, actually then we'll see if that's something like that. Obviously, oops, this is not going to compile for many reasons. The first one being nom is like, I don't know what to do with your slice of string slices because nom input is not satisfied. So that's exactly what we're going to do next is yeah, this git and then let's just go through the steps of actually now implementing nom input on this thing. So let's see. So we would do something like to do implement nom input, and then also to do fix these to do fix these compiler errors. Okay. So we got our to-dos kind of queued up, and so now what we can do is, where's this thing? Let's open it in a new window. Okay, so now what we can say is, can you implement? Yeah, there you go. So basically just asking Copilot to implement that thing. And what the heck is going on here? What? Oh, okay, this is weird. So maybe, I don't know why it's not like example 0_2 implement nom input for slice of string slices A. That's weird, like it kind of lost the context there. So nom input length. Oops. Okay, let's do this again. We can say use nom 8.0.0. This code uses nom 7. Input take does not exist. Nom 8.0.0. Please use nom 8.0.0. Nom input. Is that? Nope. Come on. All right, let's see. Okay, let's see what else we can do. Nah, that's not it. Gemini Pro. I don't know. Let's see. Okay, let's see this. This is hilarious. Okay, let's see if this works. I'm just gonna end up writing it by hand if this doesn't work. I thought I would incorporate more generative AI for source code, just I don't know, for funsies. But yeah, this has, oh my goodness, this well, you know, all that AI hype isn't true. I doubt that developers are going anywhere anytime soon. Let's see. All right, let's try this again. Ah, yes, this is the unrealized hype right here. I don't know why I'm giving it so many chances, honestly. I really want this to work, but so no matter what I say, it's convinced that nom input is actually nom input take, because that's, and then it's dealing with these slices, which, why? Okay, let us proceed to plan B. Actually, before I give up on this approach, I say I'm a glutton for punishment. Let's see. Okay, let's see if this works. No. That didn't even implement nom input. So this code does not implement nom input. Okay, so you are correct. That's right. So, sorry, what? What are you talking about? It's a seal trait. Yes, it can. Oh, okay. Holy moly. All right, let's just move on. I think we tried Gemini 2.0 Flash. Did that? But that's not, I don't know what input is talking about. That's not even the, that is not the correct trait. Nom input version 8.0.0 does not have methods you have generated, because we have the docs right here. It's like I really wanted to be right. Nope. I wonder if any of these work. 04, 03. I haven't tried this before. Let's see. Huh. Okay, maybe this prompt makes no sense. Now I'm confusing the, I'm adding confusion to the system. Why does it take so long? It's so weird. Has these 03 mini. Wonder if I hit like some kind of rate limit or something. Oh, take split, almost right. That's actually close-ish. Sure. Yeah, it's actually not, no, not exactly, but So basically it's missing 3 associated types that nom input has, which is, what is it? Item, iter. You're almost there. Your impl input is missing the following associated types, which are, let's see, what is this? Item, iter, and iter indices. Yeah, these are missing. But that's actually pretty close. Yeah, sort of. Can you remove token and slice from your impl block? Yeah, because I don't know what that is. Token and slice. It's like we just need item iter copied. What the heck is it doing? Okay, enough AI nonsense. Let's do this by hand. So we're gonna do implement backtick a. So I'm trying this in the videos. I don't know if people find it annoying. Please let me know in the comments. For actually, I don't have any comments, so please let me know in the comments for this issue for this video, because I turned off Discord and I turned off YouTube comments. So yeah, you can always email me using my email, or actually my email is here. You can also reach out to me on LinkedIn with any feedback, and you can also just leave a comment right here. So let's see, where was that? Where's this? Okay, so let's do this. So we're going to do implement nom input. Let's go look at nom input. So here's nom input. It's got like take from, all this kind of stuff. So for slice of string slices, what? Why don't I just do this? Okay. I mean, obviously there's still errors, but let's see. Let's clean this up as we go. So, okay, so we implement input for string of string slices. So the item is backtick a string. So the item, iter, and iter indices, this is like, so like for ampersand stir nom's default, the item is char. Iter is like when it's gonna chunk through each unit or item of your input. That's the iterator for it. And iter indices is like, you can almost imagine like it doesn't know how, like what's the 0th item is. It doesn't know what the item is. It doesn't know what the iterator is, and it doesn't know what the 0th item, the first item, the second item. So these are ways to tell it that. So here what we're saying is that we want an iterator. Let's see, we want an iter. And by the way, this iter thing is tied to, I think, yeah, iter element. So basically we're saying self 0, which is a vec. I mean, it's not a vec, it's a slice. And we're saying, give me the iterator, because we're not modifying it, so we don't need into iter. Like if you look at the owned implementation, this had a, where the heck is it? This had an into iter with a clone. So that was a lot of mem copies going on. So here we're saying, okay, we don't really want to modify anything. Just give me, this is the whatever the standard library iterator is. It just iterate over the string, and we're saying here, this is like when you do like collect or iter.enumerate, that's what this is. So it basically gives a it yields a usize and one of these basically. That's what it yields. So yields. So here we can say, what do we say? So okay, whatever. We'll come back and fix these. Fix that. So this is just saying wrap this thing So why don't we just say self iter, because that's this thing. That should work. Yeah, I don't know why I just copied it again. Self colon iter should be this, I think. Pretty sure. Yeah, pretty sure. All right. Okay, so we got our item, we got our iter, we got our iter indices. This one, it just says, okay, go get the iter, return the thing self.0, which is the slice, get its iter, which should be of type this, but it isn't. And why? Oh, okay. Iter blah blah needs to be an iterator that yields a string slice, but it yields a reference to a string slice because this whole thing is inside of a reference. So we just need to dereference. We just need to dereference the ampersand stir, and then that will work. But to do that, we need to see if it can do it for us. Okay, so far so good. Oh, it's saying that, oh, take and wow, some of the really interesting, so take from, and I think take split, okay. Okay, so that was, for some reason, it didn't implement, whatever. Okay, so this is working. Okay, now this needs to be, it needs to yield one of, like not stir. That's the problem, so to speak. So here we need to say, okay, so what we need to do is we need to take the output of this, and there's a way to map it to essentially that. We just like dereference the thing, but let's see. But then now it's saying, okay, this doesn't match up with that type. So expected one of these, and so let's just grab one of these. That's a lot of typing, so I am just going to do this because that's what it should be. Don't know why. Let's see. So it's a slice. Okay, so it's a map. I think that's right. It's a map of iter. Oh, backtick A, I guess. Backtick A string. What is happening? And then map iter. And then I think there's this function. Where'd that thing go? This one. See this function? This signature also needs to be added here. So it's not over yet. This is function. Let's see if you can figure it out. So basically, let's see, something like that. What is going on? Let's see, function. Oh, geez, I had the this thing in the wrong place. So basically, this collapses. So we have an iter, and the map takes this thingy. Actually, let's put it this way. This one is the something like that. Just basically, I don't want to. Yeah. So this is the whatever, the underlying iter, and this is the map function that derefs, which is, by the way, provided right there. So that's that. Okay, that's great. So let's see, underlying iter, and let me make sure to update this in the docs. Where did let's see, function that returns a string. So there we have iter map of, let's see, so the iter equals map. I see. Wow, this is complicated. I mean, it's not complicated in the sense that it's basically just like, it's supposed to be like that, and then actually, does that even need a lifetime? So this is the underlying iterator, and this is the map function that dereferences each item, basically. Each item. Okay, from the iterator, that's this one. Okay, so that's almost done. Now the problem is other indices. Iter indices. Oh yeah, this, I don't know what this is. So it should just do, it should call itself iter elements enumerate, like that was silly that it was, yeah. Because, you know, we wrote it already, it's this one. Just enumerate that thing. Okay, and then that maps, and that's this function. Whew, I think, nope, one more red. Oh yeah, now we gotta go fix this error. But yeah, this is so far so good. I don't think there's any red here. So whatever, tried to use the AI. Didn't work. All right, so I mean, but then it did, because I guess this the chat didn't work, but the inline complete was good. Was good actually. Generated most of the stuff. I mean, obviously there's a lot of, you know, cleaning up that has to happen, but whatever. It's I guess my learning is that so far, at least for now, this chat thing, talking with it in agentic mode or whatever, or not so great. But inline, it seems to know the context pretty well, so better than in the chat session, let's put it that way. All right, so now let's get back to what we're doing. So this one, now, okay, so it goes type annotations needed. Okay, so nom error. Okay, so it needs this. Okay. I wish it would just, actually, let's see if it'll just do that. Because, you know, that I was going to basically use Turbofish to just take what the error message types were and paste it in there, but let's see if it will do it for us. What the heck? I'm just going to restart VS Code. And let's see if this where is this? Okay, this was the error. I guess Rust Analyzer. What is happening? Okay, there we go, finally. Okay, so let's see. Well, but did you though? No, explicitly, but the error type is still missing. Okay, so basically it's this. It just needs to take this and put it in there. All right, let's fix using Copilot. Let's use a different model. Oh, yeah, something like that. Yeah, okay, that's cool. That was it. It copied the thing. So nom error. It's essentially like that. Yeah, that's actually right. That is pretty good. That's cool. And then this is saying, this is complaining because it's saying, oh, you know, I don't know what the types are. So it's basically a back of stir. So okay, that doesn't work. So let's just do this as back of stir. Oh, whoops, not back. What am I saying? Ugh, stir. In other words, as Oh, right, because what am I doing? It's, of course it's not that, because the thing that's inside of it is that. Sorry. Okay, so where are we? Okay, so we're taking 3 items, and then we are, so this is take the function nom combinator, right? I didn't write it. And then, but take doesn't know how to work with slice of string slices, so we implemented input, and here we have the, let's see if it works. So let's run it. Yay, it works. So basically it correctly chunked. So basically this took the, that's one string, it chopped it up with the new lines as delimiters, turned it into a vec of str, there, ampersand str, vec of string slices, which then we turned this vec into a slice itself. Now we have a slice of string slices. Then this is the type state, sorry, the new type pattern. If you don't know what that is, check out my video on it. It's really good. So then we pass that to take, and by the way, all this gobbledygook is here because we did not make a function. Normally, when you make a function to parse, you have to put this in signature. So let's do that. So this works. This is great. So one last thing is just to kind of complete the thing. So remember we had the parse hex color. Let's just take that function and let's do this. Let's make a let's do this. Say we can say for this parse hex function, replace OwnedStrings with SliceOfStringSlices. So it's just, yeah, it's just going to rewrite it, but just to make sure the types are good. And okay. What is the problem here? Oh, okay, right. We imported in our here, but we didn't in the code, so we'll put it up here. I think this is, yeah. Why is this not merged with that? That's weird. Okay. All right, so here we have, where's parse hex color. So this does whatever it's supposed to do, and let's run it to see if it works. So this would be fn test, let's say parse hex color. Let's see what it is. So it starts with a string slice, whatever, and then new line delimited, splits it by new line, collects it into a vec, turns that vec into a slice. Then now we have a slice of slices. We call parse hex color with that input. Check it out. And it parsed the, do we still have to say this? Yes, we do. Okay. So it basically then parsed the 2f into 47, 14, into 20. This is hex encoded, so let's see if this works. Bam, it works. All right. Whew. So there you go. That's let's add this. That's a really long deep dive into how to use nom without having to rewrite nom parsers, but allowing nom to adapt to your data structures, which it has no idea about. So you can then implement input for it, and then it should be good. So I'm actually going to follow this approach myself. In actually, I have real code. So let's try this. Code Insiders, GitHub, Rebel Open Core. Oops, zoom in. So I think here, I'm sorry, what? Sure. Oh, okay. I don't know what the heck is going on. Did I have, okay. So let's do this. Perf. This is the, by the way, the code I am showing now is the code in the Rebel Open Core repo, which is this one. This one. And so here we have this try, parse, and highlight, which is there. I don't know why I'm opening it here and here. I guess you can have stereo stereo code vision. So here, what happens is that this is one of the bottlenecks right now in the Markdown editor, which I'm going to fix using this approach, where the internal data structure for the editor buffer is a vec of string. It's not a vec of string. It's actually an inline vec of GC string, but close enough. But those vec of strings, notice when you call try and parse highlight, it yeah, it gets the lines, and so basically editor buffer get lines, and that takes this thing called vec. It's a vec of GC string, which is equivalent to a string. It's basically a vec of string. So what it does is that from the editor, this is on every keystroke that modifies the any content. This is what happens. So it grabs all the content from the editor buffer, and then you can ignore this. This actually allocates a buffer because the current implementation is terrible. It takes this vec of string and it serializes it into a byte array and puts back the \n that got removed in the first place. So that's what this is. And because this is so slow, I end up reserving some space to do this and increase it by some page width. It's completely overly complicated just to kind of try. Basically, there's memcopy, massive memcopy. Whatever this editor buffer is on every any edit event that mutates the buffer state, it basically turns it into one long array, puts the \n's back in, and to speed things up, it pre-allocates it and just reuses that buffer space. But then what it does is that, so here it is, write each character like 9 feet into the accumulator, which is terrible. And then it takes this string, whatever, the string slice, and gives it to the Markdown parser, which does all the parsing and returns a abstract syntax tree, a bunch of tokens. And these tokens get given to a syntax highlighter. So this basically turns a string into a Markdown. You can think of it as a DOM, but instead of document, it's Markdown. It's a MOM. And then, so this is what that thing is, the abstract syntax tree. And it's got things like this thing called MD block, which has heading, smart list text, all that kind of stuff. Then it takes that AST and then it basically colorizes it using syntax highlighting. It's all custom, so none of this is using any libraries, well, except for NOM. And yeah, so that's what this does. But the slowest part is this thing. This is pretty fast, but this is very slow. So what I'm going to do is implement input for not this byte array, but the editor text lines, which is essentially, I don't know if this is starting to look kind of, it's basically a GC string is just a string. So it's basically roughly one of these. So it's like, where'd it go? So it's like we start with one of these. We turn it into a vec of string or whatever, stir, ampersand stir, and then get a slice out of it, and then so on. So something like this can be applied to something like that, where the GC, this is basically just a string, but so I could just pull the strings out of it and make like make something equivalent to this. But it's getting closer. I'm not there yet, but one step at a time. But yeah, this is roughly lines. This happens actually in the editor. Where is it? The editor. Yeah, if you haven't seen the editor, it's pretty nice. Let's see. We'll run examples. Oops. What is this? That is not the correct folder. Run examples. There it is. What? Oh, I changed the script recently. So the editor is actually in this new run.new examples. Should probably delete all the new run examples from my history. And then actually, let me do that while this is compiling. Delete this new run example. Yes, perfect. Oh, okay, here we go. So this is, let me do this again. So let's go to TUI apps. So if you want to see the Markdown editor in action, you can see this, number 3. This is the code that actually I was talking about. So whenever you make some changes, right, so you say blah, blah, like every time a key gets pressed, this vec of strings, internally it's a vec of strings. Well, it's a inline vec of GC string, but it's the same thing. API equivalence. So this takes all the vec of every line, the vec of those lines, turns it into a byte array, injects the \ns. That got stripped out when, let's say this, you can load this file from disk, so then it will strip out the \ns and turn it into a vec of strings. And then it gives those bytes because that's how nom is expecting it. Gives it to nom, and then the Markdown parser, you know, basically figures out how to deal with this. So yeah, so this is just the beginning of the process of cleaning up the slowness. It should make a pretty significant impact actually on the performance. So anyway, I hope you enjoyed this video. If you like this style of video, please give it a thumbs up and subscribe to the channel. If you want to leave some comments and feedback, then you can do so in the issue, the GitHub issue for this particular it's in the description of this video after it gets uploaded. And also, thanks for your patience with the video last time. I did a video on Rust memory latency, which was super duper popular, and then something went wrong at YouTube, and the initial video upload got like stuck, and it just showed 360p resolution. So then I had to do a bunch of stuff, upload another version, and then do this awful redirect because there's no way to redirect. So I had to change the title card on the 360p video to point viewers to the 4K. So thank you for your patience if you were subjected to that inconvenience, and thank you for people who posted comments in the GitHub issues to bring that to my attention. With that, thank you for watching, and I will see you in the next one. Have a good day.